Welcome to the history of operational excellence. This is going to be my attempt at taking 200 years of a discipline and condensing it down into one lecture. So here we go. One of the first people we want to talk about is Eli Whitney. If I were to ask most of you what Eli Whitney's major contribution was, most people remember the cotton gin. But I would argue that he probably had a contribution that was even more impactful: interchangeable parts. While historians have shown that this really wasn't Eli Whitney's invention, Whitney was the first to popularize the idea. As the story goes, in 1798, there was a request for proposals from the government to produce 10,000 muskets during the French Revolution. Up until that point, all of the muskets in the U.S. were created by skilled tradesmen, which meant that each musket was slightly different. Of course, if you're out in the field and something were to break, you couldn't necessarily replace and fix it. You had to go back, find whoever made it, or you had to troubleshoot and try to fix it yourself, with each of the components being different dimensions. So as you can imagine, this is problematic, especially when you're in battle. It wasn't a very efficient process from a production standpoint either, and it certainly wasn't cost effective. So Thomas Jefferson had heard about a French musket workshop that was producing muskets using gauged parts by machine. Jefferson shared this idea with his fellow inventor and businessman, Eli Whitney. At the time, Whitney had fallen on hard times, and this contract presented an opportunity for a new business. In addition to improving quality and ease of repair, standardization would also lower the price point. Training forces would be easier as well. Whitney was already known for his success with the cotton gin and was awarded the contract. By 1801, he had failed to produce one musket and was called before Congress to justify his use of the funds. So the story goes, in his presentation, he brought 10 interchangeable muskets, and in front of Congress, he disassembled all 10 of them, reassembled them, and even took the group outside to demonstrate that they worked. In reality, though, it was a total lie. He secretly marked the parts so he was sure that the muskets would fire. This is the age-old strategy of fake it till you make it. While he may not have been transparent about his progress, the idea was solid, and 8 years later, he finally completed the original order of 10,000 muskets. Being so impressed with their final quality, he was ordered to produce 15,000 more over the next 4 years. Historians believe that Whitney didn't actually fully achieve interchangeable parts in his lifetime, but his manufacturing company eventually did realize his vision years after his death. The idea was adopted to produce pulleys at naval shipyards and in the metal milling operations in the early 1800s. By the 1850s, the concept had permeated manufacturing. Again, while he didn't invent the idea, and it seems as though he never realized truly interchangeable parts in his lifetime, his achievements and progress set the stage for the Industrial Revolution. The process of interchangeable parts transformed manufacturing from a high-skilled, artisan-based profession to one that was lower skilled and in much more of an assembly line production style. This ultimately increased productivity in the industry, lowered costs, and increased the number of jobs that were available to the public. An unfortunate side effect of interchangeable parts, though, was that it was really a major blow to demand for the skilled craftsmen. These skilled workers couldn't compete with high-volume manufacturing, so the professions were either completely eliminated or transformed to focus on higher-cost artistic endeavors. That being said, interchangeable parts and high tolerances on manufactured parts practically define the entire world around us today. If it wasn't for this, we wouldn't be able to fix anything around us without the help of an expensive craftsman. If you need help with your car, right, you'd have to leave it at the shop that would custom design a new part for it. Can you imagine? This is now something that we rely on, and we often take these advances for granted without really understanding how we got here in the first place. Next time you're getting work done on your car, you might want to consider giving a nod to Eli Whitney. The 1800s was full of manufacturing innovation as a result of Eli Whitney's early work. We are now using high-volume production in countless industries. With production at a scale never seen before, a few individuals started to realize that with further refinement, organizations could increase profit by finding continued improvements for productivity. Enter Frederick Taylor. Frederick Taylor was an engineer, a management consultant, and was one of the first to present operations management as a scientific discipline, publishing a book in 1909 called The Principles of Scientific Management, which applied the scientific method to improving operations. He also championed the idea that there was one best way to do a job, and he was relentlessly focused on figuring out what that was. He always went to the workplace armed with a stopwatch, taking notes and watching the movements of the workers and trying to figure out how he could make changes to improve the work that they were doing. CEOs loved the idea, and he became the most sought-after management consultant. He was supportive of the Bethlehem steel plant in Buffalo for several years and actually patented his shovel that was a precursor to ergonomics by creating less of a load on the worker's body, but also by optimizing the amount of coal that they could be shoveling. While he was able to make major improvements and forward the discipline of operations management, he also wasn't very well liked by the people that were doing the work. So think about it. You've got this guy standing over your shoulder with a stopwatch, telling you that he's got a way to do your job better than the way you've been doing it for the last 10 years, without ever really engaging those doing the work to get their insights on obstacles or opportunities. It was really demoralizing, and the term Taylorism went from being a term CEOs loved to one the workers hated. While there was an opportunity to improve upon his philosophy, he did make a major contribution to operational excellence by pioneering the use of the scientific method to improve operations, something we'll be using extensively throughout this course. Plus, he was followed by some equally influential thinkers that would pick up where he left off. Toward the end of Frederick Taylor's life, Frank and Lillian Gilbreth, this powerhouse couple, were also using his early work and research to launch their work on time and motion studies. They began analyzing video footage of workers doing a particular task to better understand opportunities to improve the output and reduce the physical demand to the worker. There are a number of videos available on YouTube that show some of their early work, particularly in the bricklaying process. By analyzing the video and recognizing the time and physical barriers created by constantly bending over to pick up a new brick during the building process, they created the scaffolding system so the workers didn't have to bend over, improving both the work environment and productivity. This may seem trivial, but at the time it was profound and encouraged many to use a similar approach to analyzing and improving their work through time and motion studies. Advancements like these permeate industries, similar to the impact of interchangeable parts, and this was truly the beginning of ergonomics as a discipline. Now, beyond their contributions to manufacturing, Frank and Lillian Gilbreth were a truly fascinating couple. Lillian was one of the first women to get a PhD in psychology. Since her and her husband did a lot of work in operations management together, they jointly worked on multiple research studies. But at the time, it was very uncommon for a woman to publish in peer-reviewed academic journals, so they published their joint work under Frank's name. But because of Lillian's background in psychology, she was really the one to start seriously looking at employee satisfaction in management's approach to creating a safe, supportive, and productive workplace. So, as a follow-up to Taylor, who really didn't have any real consideration for the people doing the work, Lillian started to bring that socio-technical component in. It wasn't until several decades later that her contribution was recognized and her name was retroactively added to the publications. She's now considered the founder of IO, or Industrial Organizational Psychology. Beyond that, this couple is fascinating because they had 12 children. They use many of their techniques in time and motion studies to optimize the efficiency of their household. A book called Cheaper by the Dozen was published in 1948, and it was a true account of this fascinating family. A fictional movie version of this original book came out in 2003 with Steve Martin and Hilary Duff, which was a very loose interpretation of this family. So during the same time, Henry Ford is making progress with the Ford Motor Company. His major contribution is the assembly line, though most of us have already heard that he really didn't invent this concept. Much like Eli Whitney, though, he was the first to popularize it and use it at scale. Ford got the idea when he was visiting the meatpacking industry. He was watching as the butchers were working on meat that was basically hung and carried along on a conveyor system overhead, with each worker taking a different cut of the meat, and he had this light bulb moment. We need to apply the same method to the production of our vehicles. So think back to our discussion of blue ocean strategy. One of the 6 paths to blue oceans is getting ideas from other industries. Using the assembly line and interchangeable parts, Ford was able to bring the price point down significantly, which made the automobile affordable enough so that a normal family could buy one. So this wasn't just great for business, it changed mobility, expanded cities to suburbs, and revolutionized travel. Okay, so now we're going to shift gears and we're going to hop over to Japan. During the same time as Ford was tinkering with automotives and considering starting his own company, a man named Sakichi Toyoda had been tinkering with ways to do things better. He'd become interested in the hand loom used by local farm families. His tinkering lasted for years, and after visiting a National Machinery Expo, he was filled with more ideas to try. He eventually created a product that worked and patented his invention, the Toyota wooden hand loom, in 1891 when he was just 24 years old. So unlike previous looms, the Toyota wooden hand loom required only one hand to operate instead of two. It removed unevenness in the woven fabric and increased efficiency by 50%. But the loom was still manually powered, which created limitations in speed. So Sakichi turned his attention to the invention of a power loom. In 1924, Sakichi invented the Type G Toyota automatic loom, which is a groundbreaking invention at the time. Though he could find a ready market abroad for his new mechanical looms, Sakichi made a radical decision that would change the fortune of the Toyota family forever. He sold his patents to his competitor, Britain's Platt Brothers and Company, for 1 million yen, or about 10,000 US dollars, which he used to start the Toyota Motor Company. Sakichi was too old to lead the new company, but he challenged his son Kichiro to build a Japanese car with Japanese hands. Sakichi was convinced of the future of cars after a visit to the US, seeing the impact Henry Ford had had on transportation. Unlike his father, Kichiro was a properly trained mechanical engineer from the prestigious Tokyo Imperial University. He took his father's challenge seriously and kicked off the process to build a car. At the time, there were less than 500 cars in all of Japan. There were a series of wartime and economic challenges that almost bankrupt the company, but they were persevered by critically examining waste and opportunities for improvement, a culture of careful analysis and experimentation that started with Sakichi. In the 1950s, Kichiro, who had successfully steered the company through turbulent war times, retired and passed the baton to professional managers. It was an outsider, someone named Taiichi Ono, who developed and perfected Kichiro's vision of Toyota production system, which could be used in all kinds of production applications, using many of the principles and philosophies refined throughout the early days as Toyota Loomworks. He experimented with various ways of setting up the equipment to produce needed items in a timely manner. But he had a whole new perspective on just-in-time production when he visited the United States in 1956. Ono went to the United States to visit automobile plants, but his most important U.S. discovery was the supermarket. Japan did not have many self-service stores yet, and Ono was impressed. He marveled at the way customers chose exactly what they wanted and in the quantities they wanted. Ono admired the way the supermarket supplied merchandise in a simple, efficient, and timely manner. In later years, Ono often described his production system in terms of the American supermarket. Each production line arrayed in its diverse output for the following line to choose from, like merchandise on a supermarket shelf. Each line became the customer from the preceding line, and then each line became a supermarket for the following line. The following line would come and choose the items it needed, and only those items. The preceding line would produce only the replacement items for the one the following line had selected. This is a concept of just-in-time that we'll come back to in a later module. But we can't complete Toyota's legacy and impact on operational excellence without talking about Edward Deming. Deming was an engineer, a mathematical physicist, and statistician during the 20th century, becoming one of the greatest quality gurus of all time. In 1947, Dr. Deming was asked by the United States to go to Japan and help with the census during the post-war restoration efforts. While he was there, he gave a series of lectures on quality and process control. Japanese companies eagerly incorporated his material into their thinking, and he began working with the Toyota Motor Corporation in the 60s as they developed a program of total quality management. Deming's work in statistics, his use of the scientific method, or what we call PDCA, or Plan, Do, Check, Act cycles, and the focus on the engagement of all levels of the organization embodied the work of all the operational excellence pioneers we've discussed so far, and we'll come back to him a few times throughout the course. Prior to their work with Deming, Toyota was known for their very low price point, but the quality was questionable. After their work with Deming, they were put in a position to win the coveted Deming Prize for quality in 1965. After that, they offered a value proposition that few others could match: exceptional quality at low prices, and they took U.S. automakers Ford, Chrysler, and General Motors by surprise. Since the 1980s, Toyota has outperformed the big three year after year and continues to reign as the most valuable automaker today. In the late 80s, three researchers from MIT started to see this shift and recognized that the production model Toyota was using was completely disrupting the industry. They went over to Japan to spend time observing the facilities, meeting with leaders, and analyzing how their supply chain operated. After these observations, they published a book called The Machine That Changed the World, which was released in 1991. They remarked at how the company was able to do more with less, a strategy that was born out of the work of Sakichi, Taiichi, and Kichiro, and Edwards Deming, among countless others. It was also born out of necessity, given the economic hardships in the 1950s. This approach to more with less was coined as lean by the researchers, and the name is stuck. If you talk to anyone at Toyota, they'll refer to their approach to production as the Toyota Production System, which we'll focus on throughout the second half of the semester. Throughout the 90s, lean permeated the manufacturing industry as the gold standard of operational excellence, setting the stage for each company to define value, map their value stream, create flow, establish pull, and pursue perfection, and we'll cover each of these principles in detail later on. Today, lean is employed in a number of industries beyond manufacturing, including healthcare, education, government, and across the service sector. Not only that, but it's the foundation for new approaches to operational excellence, including agile project management, the lean startup movement, and is being blended with other disciplines like positive organizational psychology and design thinking, all topics that we'll be covering throughout the course. As you go about your day, try to think about the ways in which these pioneers shape the world we live in today. Their individual contributions have woven together, and much of their work was influenced by others that came before them, and through these aha moments, by observing something that worked well in another industry. We'll continue to talk about these prolific authors, scientists, inventors, and leaders as we continue to evolve our thinking about what operational excellence truly means.